Hello and welcome to helpyourmath.com. In this video, we're going to look at examples and the definition of deductive reasoning. In the last video, we saw the definition and some examples of inductive reasoning. Inductive reasoning is used all the time. Basically, anytime you make a decision, you're probably applying a little bit of inductive reasoning to why you're making the decision you're making. Well, in this case, we're going to look at deductive reasoning. And before I start with the definition, let's look at an example of deductive reasoning. Okay, so I'm going to give you 4 facts, and based on these 4 facts, can we draw the conclusion that I drew? Number 1, this is a fact. Antelopes always wear yellow suspenders. Number 2, every creature that drinks syrup can play the fiddle. Number 3, anything that smells like teen spirit drinks syrup. Number 4, no creature that wears yellow suspenders can play the fiddle. So can I make the conclusion that antelopes smell like teen spirit? Pause the video now and see if you can decide whether this is a true conclusion or if we cannot make this conclusion based on the 4 facts. Have you had enough time? What'd you decide? If you decided, nope, this doesn't follow, you would be correct. So let's start. We're actually going to go, I think, from the bottom and circle back to the top. So right here, no creature that wears yellow suspenders can play the fiddle. So if you wear yellow suspenders, then no fiddle. Okay, well, what do we know? We know antelopes always wear yellow suspenders. So since antelopes always wear yellow suspenders, they must not be able to play the fiddle because that's like the transitive property at work there. And if you didn't know that, that's okay. Okay, so antelopes, no fiddle. Well, where else do we see something about fiddle? Oh, look, creatures that drink syrup can play the fiddle. Well, okay, but the antelope can't play the fiddle, so they must not drink syrup. So no syrup for our antelopes. And then anything that smells like teen spirit drinks syrup. Wait, but antelopes don't drink syrup. Therefore, they must not smell like teen spirit. So we would say, no, this conclusion does not follow. Nope. So that argument did not work. All right, on to the definition. Deductive reasoning is a type of logic in which one goes from a general principle to a specific example. So for example, all residents of New York City live in the United States. Jack is a resident of New York City. Therefore, we can make the conclusion, because it's saying that everyone who lives in New York City lives in the United States, and what we know is that Jack is a resident of New York City, we get to safely conclude that Jack must live in the United States. The conclusion follows logically from the premise. We might also think of, for deductive reasoning, not just going from a general principle, but going from a fact to make a conclusion about something that's like more specific. Well, I guess that's basically what it says. So all even numbers are divisible by 2 is a fact, and we might assume this fact that 181 is an even number. Now we know that's not true, but we're going to pretend like it is. We can make the conclusion, so this is going from everything, the general, to a specific example that allows us to make a deductive reasoning conclusion that 181 must be divisible by 2. And we might notice here that logic doesn't necessarily provide a true statement, because if you have something, a fact that is wrong, such as 181 being an even number, you can draw a correct logical conclusion, but it's not necessarily true because your facts were wrong anyway. So we frequently say that logic is not the same as truth. Another way in which we might use deductive reasoning is in algebra. So we would say 5x equals 15, and we want to solve this using deductive reasoning. Well, what would we need to do to get x by itself? We would need to apply a generally accepted principle or property, which is the multiplication property of equality. And what that says is that if we multiply both sides by the same amount, then it does not change the equality. Now you might say, wait, why am I going to multiply? Well, because division is actually multiplication in disguise. So even though you would divide both sides by 5, what you're really doing is multiplying both sides by 1/5. So we could divide both sides by 5. This would be deductive reasoning because we're taking a known fact, the multiplication property of equality, and we're applying it to one single example. So we would say that x equals 3. And that is deductive.